Good morning, good afternoon, or good evening, depending when you're watching this video. I'm going to quickly go over some examples of the problems that you're going to have on the Pythagorean theorem test. So here's our first example. Here we go. By the way, this is my first video, so be patient with some errors I may commit along the way. Okay. So here we have a right triangle. As you can see, the height is 6, the base is 13, and the hypotenuse, which is the longest side of a right triangle, is unknown. So we're gonna leave that as a variable. So as you know, we have a Pythagorean theorem. You know, it's a squared plus b squared is equal to c squared. Okay, this equation is known as the Pythagorean theorem. So I'm going to use this to figure out what is that distance from here to there. Okay, so as you can see, I allowed the height to be a, the base to be b, and c is just c, the hypotenuse is just c. So here I went ahead and I substituted into the Pythagorean theorem. A is 6, so I plugged it in here, 6 squared. B is 13, so I plugged it in here, 13 squared. And c is unknown, so I left it as a variable, c squared. So you know 6 squared is 36 because 6 times 6 is 36, and 13 squared is 169 for the same reason. And 169 plus 36 is equal to 205. So I brought that down. The next step, I went ahead and I needed to cancel the exponent. So I square rooted c squared, and I square rooted 205 to get c has an approximate value of 14 and 3/10. Okay. All right, now let's move on to the second problem. Here in the second problem, so hold on, give me a second. Adjust this. So in the second problem here, we have another right triangle. The height is 15 inches, the base is unknown, and the hypotenuse is given to be 51 inches. Okay, so once again, I applied the Pythagorean theorem, and I brought it over here. It says, okay, 15 squared plus b squared equals 51 squared. Okay, and then 15 squared, you know, is 225. B squared is b squared. 51 squared is 51 times 51, which is 2,601. So since this time we're trying to find out the measurement of a leg, instead of adding these two, we're going to subtract. So I subtracted 225 from both sides. It forms a zero pair on the left-hand side, so that goes away. B squared comes down. 2,601 subtract 225, we get a difference of 2,376. I squared both sides to get 48.7 inches. So the length of the base is 48 and 7/10 inches. Okay, moving along to the example 3. Here in example 3, we have another right triangle. The height is not known. The base is known to be 32 units, and the hypotenuse is 79 units. And as you can see, I allowed A to be the leg 32, B stayed as B, and C is the hypotenuse, the longest side of the right triangle. So I went ahead and I substituted into the Pythagorean theorem. So 32 squared plus B squared equals 79 squared. Okay. Then I went ahead and evaluated the exponents and got 1,024 plus B squared equals 6,241. Then I subtracted 1,024 from both sides of the equation to form a zero pair. And the whole goal here is to isolate the b. We want to find out what b is. Then I went ahead and square rooted both sides to cancel that exponent. And so this radical symbol is going to cancel with that exponent, and it's going to be b all by itself. So now the square root of 5,217 is approximately 72 and 2/10. So this distance from here to here is 72 and 2/10. So notice it's slightly less than the hypotenuse, okay? Slightly less. Legs will always be shorter than the hypotenuse. Something you should know by now. All right, next, let's move on to example number 4. Okay, so example 4, give me a second. Let me scoot this up. Right about right there. Okay. So moving on to example 4. Here in example 4, we have another right triangle. And in this right triangle, as you can see, we have the height 6 units, the base is 5 units, and the hypotenuse, once again, is not known. So I went ahead and applied those values into the Pythagorean theorem. So we got 6 squared plus 5 squared equals c squared. 6 squared is 36 plus 5 squared is 25, and that is equal to c squared. Okay, I went ahead and combined like terms to get 61. 61 equals c squared. Then I applied the square root to both sides to get that c is approximately 7 and 8/10. So what that means is 7.8 multiplied by 7.8, it's approximately 61. Okay, so the distance from A to B is about 7.8. Let's move on to the other side. Which set of side would make a right angle? Which set of sides will make a right angle? So let's see. Here we have a couple options, and I know you can see the answer already, but we were given two sets, one measuring 9, 10, and 12. So this is a leg size 9, another leg size 10, and then a hypotenuse of 12. So, but we don't know if those are. So what we did, what I had to do is go ahead and plug it into the Pythagorean theorem. And as you can see here, you can see everything I did there. So we have I applied these values in the Pythagorean theorem. 9 squared plus 10 squared equals 12 squared. 9 squared is 81, 10 squared is 100. When you add those two, you get 181. And as you can see, 181 does not equal 12 squared, which is 144. These two do not equal each other. Therefore, there is no way you could build a right triangle with measurements of 9, 10, and 12. Now let's move on to 7, 24, and 25. Is it possible to build a right triangle with measurements 7, 24, and 25? Well, let's see. So let's see, 7 squared plus 24 squared equals 25 squared? Question mark. Well, you evaluate the exponents. You get 49 plus 576 equals 625. And as you can see, the sum of 49 and 576 is 625. They both equal each other. So this shows that, yes, it is possible to form a right triangle with measurements 7, 24, and 25. Okay, I'm going to go ahead and pause, and I will come back and show you the other examples on another video, okay?